Hi there! Today we're going to be talking to you about coding in schools. But before we get going, we really need to consider what coding is. It can sound really intimidating, especially for those of us who aren't as fluent with computers. You know, we hear names like Python, C++, C#, Java, JavaScript, PHP, a lot of three-letter acronyms, and it can get pretty intimidating. But really, we just have to boil it down to, in essence, what is coding and how can that be useful in our schools for our students. Coding isn't really something new. Coding has been around for centuries and centuries. It was being done before computers were invented. If you think about it, even language in a way is a code. We use symbols to represent deeper meanings. And when we code on computers, we do a very similar thing. We use a language that the computer can understand in order to give it instructions so that it reacts in a certain way. Coding, in short, is communicating to a computer a set of instructions to achieve a desired result. But the process of computer coding is what's really interesting in its applications in the school. So the process of coding usually starts with a problem. There's some sort of problem that we want to solve, something that we want to do. And we have to come up with a plan as to how we're going to do that. That plan is usually called a pseudocode, and it's a set of instructions, sort of like a recipe, of just the step-by-step breakdown of how we're going to do what we want to do. Computers aren't so good with abstract concepts, so we really have to break things down for them. Once we have that pseudocode, that step-by-step plan, the next step is to turn it into source code, which is the language that the computer understands. So we turn that pseudocode into a source code. We translate it, if you will, into a language for the computer. And those are where those words like C++, C#, Java come in, because those are the languages that computers understand. Once we have that source code, we then tend to run it through the computer, and it rarely works the first time, which is where this process of revision and editing comes in, and that's the essence of computer programming. Most time is spent revising a program and trying to get the bugs and glitches out of it. So when you get down to it, what language you're learning is often less important than the process and the procedure of writing the code. From this process, connections to the classroom can be seen quite clearly. The process of writing a pseudocode is a lot like writing an outline of an essay. You need to know where you're going. The process of refining the code and re-planning, encountering those problems and finding the solutions to them is important for mathematics, it's important for science, and even going back to that writing of an essay, it's an important procedure in reviewing an essay and editing the essay. And then of course there's a whole bunch of more reasons, and that's what we're going to share with you now.
Alright, so Tiff has talked to us a little bit about what coding actually is. And now we're going to talk about why the heck would we want coding in our classrooms? What are we going to say to the inquisitive kid who asks us, you know what, why do we have to learn this? And we'll say to them, because. And of course we'll give them a couple reasons. Because number one, well, it's just a fun way to do it. It's a fun introduction to what computer science is about. And because number two, because we want more geeky girls in this thing called computer science, or for these girls that think computer science is cool. Because number three, that coding is the 21st century's new literacy, and they of course need to be literate, and this is very important. And the last because is coding teaches the skills, or job skills, that are very important to you. But let's talk about them a little bit. Let's talk about those reasons. Are they actually good reasons? Are they good becauses? From my point of view, at least, because number one, and because number two, and because number four are good reasons. Why do I say that? So let's talk about number one. Coding is a kind of a fun way to get into what computer science is all about. I mean, coding pretty much forms the basis for most of the fields in computer science. You got software engineering, you got hardware engineering, these kinds of things. And you can't do that without some knowledge of code. And two, computer science has always been sort of the guys club. And you know what? There's nothing theoretically that prevents girls from being just as awesome in the field as guys are. So why not encourage them as well? Before I talk about 3, I want to talk about 4, because I think it's a better reason at least. Tiffany talked about, coding can encourage creativity, can encourage problem solving, logical thinking. If you have an activity that you can use as a teacher to encourage creativity, to encourage problem solving, to encourage clear thinking, that's a pretty powerful tool, something that we definitely would probably want to consider when we're teaching our kids. But let's get to the most controversial reason, or at least in my opinion. That is whether or not coding is indeed the new literacy of the 21st century. Well, Microsoft at least certainly thinks that this is the case. This is a quote from Sylvie Lafarge, the director of the European Union Institutional Relations and Citizenship. And she says that coding teaches broader skills such as creativity, flexibility, and problem-solving abilities, and can empower our children to understand the world around them. Coding truly is the new literacy, and it should be treated as such. Well, obviously that is a pretty strong opinion from Microsoft, but for me it raises a couple of questions. For instance, is in fact the knowledge of coding that critical to teach? Is it more important than, say, math? Is it more important than reading? Is it more important than all the things that we have been talking, or that have made up education as far as this particular knowledge the most important for the 21st century? And is coding the method to teach creativity, to teach flexibility, to teach problem solving? Is it the only method? Maybe, maybe not. And the last thing perhaps is that coding might allow children to understand the tech around them. Certainly coding will tell you, that computers run on instructions that you give to it. But does that allow them to understand then the world around them? It might help them understand the tech around them, but does that help them to understand their friends, perhaps? Does that help them to understand greater things than that? That is the question.
Hi, I'm Miles. I'm passionate about computers and technology education, especially programming. During this next segment, I'm going to talk about an organization that is doing some very important work in Canada. CACS, or Canadian Association of Computer Science, is an association that promotes computer education across Canada. The president, Dr. Ken Barker, is an active computer scientist who works mainly on privacy-preserving data repositories. His mission statement in regards to CACS is to increase interest in Canadian youth in the study of computer science and its many areas of research and application. There are other associations that have been active in Canada, like the Computer Science Teachers Association, which is affiliated with the Canadian Association of Computer Science, but they largely work out of the United States. The Computer Science Teachers Association does have many documents that can help teachers build advocacy groups and programs in their own schools, however, and is certainly worth investigating. It is important for Canadians to have their own take on how to build advocacy for computer science and programming in Canada, however. Local initiatives that are aimed at helping future Canadian programs are important for building a community that specifically has a Canadian identity, with an understanding of the challenges and opportunities in our own wonderful country. Keeping that in mind, there are a few initiatives that the CACS are running that are outstanding in helping Canadian students achieve greatness in computer science. The organization recognizes outstanding young computer science researchers annually for their contributions to the field. This is generally reserved for post-secondary students or recent graduates, but the awards are based not solely on academic contributions. There are many social components that recognize the promotion and awareness for Canadian computer science. A full list of the recipients is available on their website with detailed information on each recipient. CanComp Ed Day is another important initiative focused on bringing attention to computer science education in Canada. The purpose of this event is in recruiting and retaining students to meet the growing demand in the workforce for computer scientists and providing basic computer science literacy skills. February 21st, 2014 CanComp Ed Day was a major success across the country in almost every province. Much like the physical literacy movement in the Canadian schools, computer literacy is an important idea that CACS is working hard to promote. Having basic understanding of programming and computer science is important for every student, even if they decide to pursue something wholly unrelated to computers. Lastly, in an effort to promote future events, students from all over Canada were asked to submit projects that show excellence in computer science. These students were celebrating the recent promotional YouTube video that was created for CanComp Ed Day. The video can be seen on their website, which has some fascinating Canadian computer science educator commentary. Along with initiatives like the Hour of Code, which 5 million Canadians participated in, Coding for Kids, Family Half Jab, and Brilliant Labs, the CACS is doing a wonderful job of building programming skills for young children. There's a good chance there will be an event near you in the future, so it's important to take a look at the CACS website and make a note of their upcoming events.
It's hard to imagine a single career that doesn't have a need for someone who can code. Everything that works has some type of code that makes it run, and it's all around us. Coding will help with critical or logical thinking. You ask yourself, to accomplish this, what must I do? It helps you understand math. You ask yourself, how many degrees do I have to rotate to do this? And it also helps you sweat a little, for those of you who want to lose weight. You ask yourself, why isn't this working? And lastly, it helps you be resourceful. If you're not succeeding in it, you ask yourself, has anyone succeeded in this? And then you want to find out, what did they do to make it work? I'm going to talk about a lot of resources that are available to students, teachers, and even parents who have no coding experience. But first of all, I'd like to start with the most popular one. It's called Scratch. And I'm sure a lot of you have heard of it. Scratch is one of the most popular coding tools for students. It is designed to help students with little to no coding experience dive headfirst into programming. This software helps students create animations and stories with building blocks that mimic the structure of computer code. It comes with a web-based beginner's guide or downloadable PDF version. We also have the Codable, it's spelled with a K. It offers free 1 hour of coding. You can use this on an iPad, and it's for ages 5 and above. We have the Live Code, which offers free downloadable materials by age level. It can be used on iOS or Android devices. We have the Minecraft.edu, which lets you install and use Minecraft in the classroom. It requires purchase though, it's not free. We have the Lego Mindstorms. It's been around for years. The newer NXT kits have cool robots that can be made and programmed. We have the Tinker games for the elementary students to learn how to code. We also have Hopscotch. This is free, and you can use it on an iPad for upper elementary schools and above. It offers an excellent ebook, which is free, and it poses challenges for students and engages them in the activity. You also have to activate your emoji keyboard.
So now that we know a little bit more about coding and how it can be useful in the classroom, we're going to do some first-hand learning of our own. They say that experience is the best teacher, so we're going to put that into practice and give it a try. We're going to be using a programming language called Logo, and I think it's pretty fun. So I'm going to give you a moment now to open it up in your browser. The site you're going to go to is Calormen, CALORMEN.com/JSLogo, LOGO. This is what the site should look like. So I'll give you a second now to go open that in your own browser. Once you've come to this page, you'll notice on the top right you have these things for reference, library, history, examples, extra, links. Reference is very helpful. It gives you a list of all of the commands that you can do in this interpreter. We're specifically going to be using things found in the graphics section, and it says things like turtle motion. So what that means is, you'll notice this triangle in the center of your screen. Imagine this as a turtle with a pen in its tail, and we're going to give it commands to walk around the screen. So you'll notice things like forward, and then it says expression. So if we go down here, type your code here, we're going to type that FD, which means forward, and however many pixels we want it to move forward. So 400 is too far, so it moves back around the screen. Left an expression, you can do LT, and then you're going to do some number of degrees. So let's say 45, and then we're going to go forward again 70 pixels this time, just so you can see how you're controlling the turtle. So take a couple seconds to try around with that, and then come back. Alright, so now that you've made a mess of your screen, one thing that's really helpful is clear screen, which gets rid of everything and puts the turtle back in the middle of the screen. So once you've done that, come back again. Now you'll remember from my first segment, I was talking about how we start with a problem and we need to make a plan. So I'm going to go over to a Google Doc, and I'm going to make a logo organizer, we'll call it, because it'll have our task and our plan. So this time our task is going to be simple. We're going to draw a house. Now, I'm not sure for you, but when I imagine a house, I imagine a square with a triangle on top. So now I have to think of the easiest way to get my turtle to do that. Probably I'm going to start with the square. I like squares, so I'm just going to start with that. So square you can do, if you imagine it, you're going to go forward and then turn and then forward and then turn. And go forward again until you have all four sides. So that's what it's going to look like. So I'm going to write forward, turn, and that turn is probably going to be 90 degrees, right, to make a nice sharp right angle. I'm going to go forward, I'm going to turn, I'm going to go forward, I'm going to turn, and then I'm going to go forward, and that's 1, 2, 3, 4 forwards. So that should make a square. And now to make the triangle on top, see, hopefully if I do this right, I can make it so I end up on a top corner. So I'm going to just make sure that I'm saying turning towards the bottom first, so that that first forward run that I do becomes the top of my house. So to make that triangle on top, it's probably easiest to do an equilateral triangle. And I know that the interior angles for an equilateral triangle are 60 degrees. So if I use that, and then since it's equilateral, I can do forward the same as before. And that should draw a triangle on top of my house. So I'm going to go back to my logo interpreter, and I'm going to try that. So I said that I wanted to do the top of my house first, so I wanted to turn towards the ground first. So right now I'm facing in the wrong direction, so I'm going to go left, or I could go right. I'll go right, why not? 180 degrees flips me around. Alright, and then I'm going to do that forward. I have to decide the length. Why don't I make it 150? So I'm going to go forward 150, and now I'm going to turn to, I can pick left or right. We'll go left, 90 degrees. Sure, that should work. And now I'm going to go forward 150 degrees, or 150 pixels. I'm going to go left again. This is the trick now. I have to remember to make sure that I'm turning in the same direction each time now. And then I'm going to go forward 150. And I'm going to go left 150. Oops. I see, you can make mistakes like that. So I'm going to undo that by going right 150. I'm going to go left 90, and then forward 150. So now, before I do it, why don't you try on your own to make the triangle that is your roof? I'll give you a couple seconds for that. Alright, so hopefully you've given it a try. Now I'm facing this direction, and I'm going to want to come back here and face this direction. I want the angle from this line here to the line of my roof to be 60 degrees. I said that that comes from the equilateral triangle. So I'm going to have to go 180 degrees minus 60. So I'm going to be turning right 120 degrees. And then I can go forward 150. And then I'm going to go right, and this time, let's see, 180 degrees would put me back here. I want 60 here, so I'm going to go 120 degrees again, and then forward 150. And from there you can see I've built a bit of a house. Maybe what you can do on your own is add some doors in. Think about how you could get around to add doors and windows. And I hope from this you can see too that this can be a really fun thing. It can be challenging, and certainly for what we're doing it requires a knowledge of math and geometry, but it can really be quite enjoyable. So I encourage you to continue playing with this on your own, and to think of maybe some ways you could use something like this for probably intermediate, maybe junior grades, maybe in math class, maybe in other courses. Maybe you want to design a logo, that's what the name is. Maybe that could be something that you'd want to do in an art class. But now you have an idea of one language, and you can see how you can continue to learn more using the reference here for the different commands. And from that you can just explore and learn on your own and work with students and have them teach you as you go as well. So I hope you've enjoyed learning about coding, and I hope that maybe you'll continue to learn, even if it's just messing around with Logo in your own spare time. Thanks very much for your time.